Okay, so this example is one of the more difficult example. Okay, so it's very generic. You realize that the question is very short. There is no expression for you to prove. So there's no guiding. They don't guide you part by part like as with all the previous question. So most of the time, a lot of students will have issue with this type of question. So you need to be very patient to be reading. So in this question, right, if you start reading, you realize that it just start with a piece of wire that is 10 centimeter long. So it's just start with a piece of wire that's 10 centimeter long. And then one of the piece is X centimeter. So it's something like this part is X centimeter. So if the first length is 10 centimeter, then the second piece will be 10 minus X centimeter. Okay, and then the first piece, we're going to be forming into a circle. And this one, I'll be forming into a square. So when you use a piece of wire to form the shape, so apparently, right, they are indirectly telling you the perimeter. So like the perimeter of the square is 10 minus X. Then the circumference is X. Okay, so the piece of wire should be related to the perimeter and the circumference. Okay, so that's the first thing that you come up with first. Okay, the critical thing is to understand the question. Okay, to show that when X varies. So the idea of X varies means later on differentiation is involved. So you are differentiating with respect to X. And what are we differentiating? We are differentiating the sum of the area. So the sum of the area enclosed by the two pieces of wire. So if we break down this idea, it's just as good as the area of circle plus the area of square. So it's like a big capital A. So the sum of the area enclosed by the two pieces of wire. So obviously it's just the circle and the square. So you will need to find the area, but you only have the length. Okay, so bear in mind that. And later on, your job is to execute the idea where area is minimum. So when area is minimum, what happens? That means later on, you'll be differentiating with respect to X. And then eventually, you're trying to get a radius. You're trying to get this radius. So your job is to show this radius. So that is the whole question. So you realize that you don't have the expression even to differentiate. Okay, so you got to target the parameter first. Okay, so how are you going to target? So first of all, the circumference of the circle is X. Okay, what's the formula for circumference? That will be 2 pi r. From the 2 pi r, my interest is to find radius. Because only when I can find my radius, then I can find the area of the circle. Then I can find the area of my circle, which is pi r squared. So this question is a little bit difficult because whatever you are going to show is in terms of pi. Meaning, right, throughout your working, you got to make sure your working doesn't have 3 SF. you should leave your working as much as possible in terms of time. Okay, so that will be the first part. Okay, I managed to get the area of the circle already. So the next one, I need to get the area of the square. So I only know that the perimeter of the square is 10 minus x. So what does that tell us about the side of the square? Okay, because it's 4 equal sides, that means, right, each side is the perimeter divided by 4. So from here, I'll be able to get the area of the square. So I simply just need to square the length. So I simply just need to square the area of the length. In this case, I'm not going to expand the bracket. I'm just going to let it be. So that is the area of the square. So eventually, I'm interested in the total area, meaning this and this to be added up. Okay, so for this part, I'm going to be writing in this manner to facilitate the differentiation later. And then I'm going to add the area of the square. So that will be the expression that I'm dealing with. So this is the area that I'm interested, and this is the area that I need to make it minimum. So as we explained just now, I will need the area formula first. Then I'm going to do a dA dx. Okay, the reason why I isolate this part is because it's a constant, then you just differentiate your x squared. And then for the second part, I'm just going to do a chain rule. So bring down power, minus power, and differentiate inside. Okay, so simplify it. So we can write it this way. Okay, let me write it nice. So I'll write it as 10 minus x over 8. So once I get this expression, as the theory says, when a is minimum, dA dx equal to 0. So this whole expression is equal to 0. So you will be able to get the x. So what are you trying to do when you set dA dx equal to 0? In this case, you will be able to solve for your x. So because it's two fraction, I'm going to bring the fraction over to the other side. So I do my simple cross multiplication. Okay, I will do my simple cross multiplication. My aim is to find x, and I'm not trying to press out my 3s. So I'm going to find my x. You group all the x to one side. So it behaves a little bit like make x the subject. So I'm making x the subject. Okay, and if you look at the expression for x, you can actually simplify. Everything can be divided by 2. So this is the expression for x. But you realize that it looks different from what the question wants, because the question wanted the radius. You are not getting the radius. So at this point, you are not getting the radius yet. Where is your radius? Your radius is here. Your radius is x divided by 2 pi. So you still need a further step. Okay, I'm going to squeeze my working on this side. So the radius is actually x divided by 2 pi. So put in the x that you have found And when you divide by 2 pi, it's as good as multiplying this. Do a reciprocal. So from here, you realize you can cancel. So you got the radius. So eventually, when that means you got the radius when A is minimum. So this is what you have shown. Okay, so the whole process is quite long and it's not so easy. Okay, so this is one of the harder questions. So I'm just trying to show you like this kind.